Assalamualaikum and a very good day to everyone and our lecturer, Dr. ZT. We are Group 7 here to present our group project.
Assalamualaikum, my name is Muhamad Hussan. My mature number is AF190196. Introduction. Restrained slopes are uncovered ground surface that are at an angle with the horizontal. The slope can be natural or artificial. Gravity will tend to drag the dirt downhill if the ground surface is not horizontal. Landslide, slips, slumps, mud flows, and rock falls are just few of the words used to describe the movement of soil and rock caused by gravity. Soil and rock slopes are discovered in nature and man-made structures. The soil type, soil stratification, groundwater, seepage, and slope geometry all influence slope failure. A flow slide happens when internal and external factors drive soil to behave like a viscous fluid and flow to even shallow slopes, spreading out in various directions. Slope collapse are generally caused by natural factors, human errors, and varying animal activity.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad bin Abid bin Muhammad Sidek, AF190025. Today I'm gonna to present about literature review. Firstly, the techniques of slope stability remediation. From Muhammad 2015 slope remedial work at Bukit, Malaysia. The first method is they use reinforced concrete retaining wall and soil net, while the second method involved the use of a creep wall and soil net. This study shows that the use of reinforced concrete, RC retaining wall, and soil nail have a higher FOS value compared to the use of a creep wall and soil nail. From Shantanu Sankar and Manoj Samantha 2017, which is Stability Analysis and Remedial Measure of a Landslip at Kefa, Mizoram. This study proposed that two types, which is RCC retaining wall and gabion wall. This study shows that gabion wall is chosen because the FOS is 2.99, which is bigger than RCC retaining wall due to gabion wall's bigger safe weight at slope to boost the slope resisting power and provide a higher factor of safety. Lastly, slope stability analysis Bishop method, deep excavation 21 from the internet. This article said that slope stability analysis can be determined by using Bishop method to discretize the soil mass and determine the factor of safety. This method achieves vertical force equilibrium for each slice as well as overall moment equilibrium around the trial surface center. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq bin Jamaluddin. I will explain about best choice of techniques to remedial the slope failure based on case given and the reasons why we choose the techniques. So the remedial measure is chosen based on feasibility, stability, and because. Precautionary action consists of identifying landslide prone areas, identifying early warning indicators, and using slope assessment tools to determine the best approach for their remediation. There are two important variables that contribute to slope instability, which are the saturation of the subsoil, the build-up of pore water pressure. The risk of pore water pressure and subsoil saturation building up can be reduced with good surface and subsurface drainage system. To reduce the effect of large volumes of water absorption by the slope, surface drainage can discharge water, especially during heavy rain. So, surface drainage techniques are simple to implement and provide excellent slope protection. Erosion control systems such as diversion ditch and interceptor drains are commonly used, especially in circumstances where substantial amount of runoff are expected. Picture shows that surface drainage of slope using diversion ditch and interceptor drain. As stated previously, increasing the shear strength of the soil by subsurface drainage is one of the most efficient remedies for landslide and other unstable slopes. Drainage reduces excessive pore pressure in the soil mass, resulting in a higher effective stress on the potential failure surface. So this slide will explain why we use the drainage method. Because of its weak geological structural characteristics such as high topographic areas, big slopes, and large discontinuity content, the slope conditions in the Bukit Antarabangsa are considered less stable. The high amount of moisture seeping into the soil weakens the soil structure and accelerates the weathering process, resulting in sandy soils. A high percentage of cavity space increase soil porosity, which increase infiltration rates even more. The lack of water retention in the soil caused by low aggregate stability caused by low organic matters. Meanwhile, the hydraulic velocity of the soil's conductivity is affected by the rate of water content in the soil. Lastly, increased groundwater content because of quick infiltration due to the high rainfall intensity. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Zulhairie bin Zaiful, metric number AF19005, and I will present about application of any standard regarding to JKR guideline for slope design. JKR stated material used in the construction of field slope and embankment shall, if is suitable, rock excavated from cut maximum size of individual pieces not larger than 100 mm. Drying out of the field material during hauling and handling from cut to position of placing shall have to be allowed for. Depending on the subsoil condition encountered, settlement analysis for field slope and embankment will be performed. And lastly, field slope and embankment must be designed to allow 90% of the settlement during construction. The engineers also had to do the slope stability analysis that include stability analysis for the temporary stability measured during construction. Second, cut and field slope stability should include both circular and non-circular analysis and in a multi-mode of failure. And last one, any slope that is influenced by the surcharge load should be analyzed by taking into consideration of the surcharge load. Other than that, all untreated slopes should be designed with the maximum beam width of 2 meters, maximum beam height of 6 meters, and a factor safety greater than 1.3. For surface drain in the slope shall be provided in addition normal cut-off drain at the top of the slope. Downslope surface and drain shall be provided for all cut and field slope surface. The drain should be cascade drain and handrail for ease of maintenance in the future. All surface drains should be cast in situ and should be designed to follow guideline for road drains drainage, Volume 4 Surface Drainage, REAM GL 3/2002. For subsurface drainage such as horizontal drain and drainage blanket should be provided for cut and field slope and for area where groundwater level is high. Lastly, all subsurface drains should be designed follow the guideline for road drainage design Volume 5 Subsoil Drainage, REAM GL 3/2002. Guideline for road drainage design Volume 4 Surface Drainage, REAM GL 3/2002 stated for surface drain guideline. The function of the surface drainage is to remove excess water from the route about by rainfall. Surface drainage system is a bulk area are generally connected to other drainage systems such as storm sewer, lakes or river. Preventive measures include changing of the water course, intercepting and disposal of water, bank protection and soil treatment. This is the standard set by the REAM. For the subsurface drainage guideline by REAM, objective of the subsurface is to make sure that the subgrade of uniform bearing value and the strength is maintained. The installation of the subsoil drainage should be based on the site condition at the time of the construction. When the water table is relatively close to the formation level, which is less than 1 meter, the engineer is required to conduct soil classification test, grading test, trial pit to a specific water table level. Surface drain guideline by RIM GL3/2002. There is condition. First, intercepting seepage water from the outside sources and lowering it to the acceptable level before it reaches the road structure. We can refer this in figure 5.1. B. The removal of stationary water in the soil to control and to lower the groundwater table and providing outlet. We can also refer this in figure 5.3 and figure 5.4. And the last one, C. To drain the subgrade and pavement during and after the construction period. Figure 5.5. This is subsurface drain figure 5.1. Longitudinal subsoil drain used to cut off seepage and lower the groundwater table. And here all the parameters being given. Figure 5.3, symmetrical longitudinal drain used to lower the water table. Also we have the water parameter given here. The next one is figure 5.4, subsoil drain for multi-lane road. And this is the lane 1, lane 2, and this is the subgrade. And the last one, figure 5.5, subsurface drain, subsoil drain to directly drain the base course. And this is all the parameter given on the design. And that's all from me. Thank you.
Assalamualaikum and a very good day. My name is Mohd Syamil and I will present you the long-term stability for the chosen technique. So firstly, long-term drainage performance monitoring is critical for defining proper prescription for future projects. For our method, we will use the drainage method. Thirdly, surface drainage offers a potentially effective means of safely transporting water down steep hills. So for the capacity, it is enough to manage a 10-year peak flow. So for permanent pipe slope drains should be sized for maximum flow of 25 years. So for the material, it needs to be strong, flexible pipe such as heavy duty, non-perforated, which means it doesn't have holes, and corrugated plastic. Moving on with the common trouble points. Firstly, inadequate compaction, insufficient fill or placement too close to the edge of the slope might cause washout along the pipe owing to seepage and leakage. Overflowing of a diversion due to a clogged or undersized pipe. The drainage area may be too large. And thirdly, erosion at the outlet. Fourthly, do not divert more water to the slope drain than the slope drain was designed to handle. And next, for the maintenance part, once a week and after each rainfall event, inspect slope drains and supporting diversions. Check for settlement cracking or piping holes. Repair as soon as possible. Thirdly, look for seepage holes where the pipe emerges from the dike. Repair as soon as possible, and examine the conduit for signs of leakage. Repair as soon as possible. Examine the outlet for signs of erosion and sedimentation. And lastly, remove temporary diversions and slope drains. Okay, that's all from me. Thank you.
Conclusion. When the Earth's surface is at a particular angle, the shear force in the soil serves as a force retainer against gravity, causing considerable geostatic stress. Landslide occur when the stress exceeds the soil shear force. Aside from that, development in the upstream area will increase the amount of water that flows downstream, contributing to land failure. The building of a drainage system or a retention pond allows the running water to move safely. Landslide occurred in Bukit Antarabangsa, Selangor is the result of water overflow from the construction upstream. This demonstrates that slope remedial work should not be overlooked and is necessary for successful slope stability. Apart from soil stress, whether lateral or horizontal, the climate element in Malaysia, which is hot and humid, leads to soil failure. Even if the failure is minimal and only affects a few slope surface, if the failure region is not covered with soil restoration, the soil will be exposed to the sun and rain in the long run. Most slopes encounter merely use blue plastic covers to cover the slippery or corrosive surface as a temporary way to keep precipitation and air out of the soil.
Okay, that's all from us. Thanks for watching.